morning everyone. Okay. So whether you can see the board, all of you? Okay. Yes, good morning everyone. One minute. Mayank, can you increase the brightness? Because whatever they are texting, I have to go nearby. Yeah. Thank you. Shift it down. Yeah. That's perfect. Thank you. Okay. So, good morning everyone. So, we'll start with the class. Now, if you remember, in the last class we have discussed about factors affecting the equilibrium, right? So, which are those factors we have discussed? That is with respect to temperature, then that is with respect to pressure, then concentration, right? And finally we have the catalyst. Now when it comes to temperature, we have focused on exothermic and endothermic reaction. So what will happen if I supply the temperature from outside for an exothermic reaction? What will happen if it is endothermic reaction? That's what we have discussed. From outside, if I supply the temperature to the reaction solution, for an exothermic reaction, it's going to decrease. Okay, board is not clear. For everyone, it is same. Now, it's clear? Now whether it's clear? Okay, fine. So Rakesh, now for you, board is clear? Rakesh? Ashish, yes sir, clear. Okay, done. Okay, so that's why we have the factors which is going to affect the equilibrium, right? So blurring, sir, it's blurring. Blurring means 1 minute. Okay, I think it is decreased now, right? Now it's fine now, Rakesh. So that's where we have the factors which is going to affect the equilibrium of a reaction. Now when it comes to temperature, for exothermic reaction, if you supply the heat, yes Rakesh, thank you. So when you supply the heat from the outside, so naturally it's going to decrease the reaction if it is an exothermic reaction, right? And when for endothermic reaction, if you supply the heat naturally, it will going to go for forward direction. It will show the forward direction. Now when it comes to the pressure, as we have discussed as an example with respect to Haber's process. With respect to the pressure, it depends on the number of gaseous molecules on the reactant side and the product side. Now when you increase the pressure, if on the product side less amount of gaseous molecules are there, then product formation is going to be increased. That is with respect to the pressure. Now when it comes to the concentration, naturally a reaction has taken place. It has reached to an equilibrium. Now if you start adding the product, then once again the equilibrium will be disturbed and it will move to the leftward direction. So that's where we have the concentration, effect of concentration. Then finally we have the catalyst. As I told, catalyst is not going to alter the equilibria, but it helps in the attaining the equilibrium at faster rate. What I mean to tell you is it's going to increase the rate of the reaction. Fine? Yes. So that's where we have the factors which is going to affect the equilibrium constant of a particular reaction. Then based on that, we have discussed about, yes Rishi, why good night? Okay na? So based on that, we have discussed about Lee-Chatler's principle. Very important, right? So what is that Lee-Chatler's principle? It tells that a system which has reached to the equilibrium, if you alter the condition, now what will happen? It will try to attain, or it will try to readjust itself in such a way that it will attain the new equilibrium. Okay? So why it will readjust itself? To nullify the effect of change in the condition. That's what Lee-Chatler's principle talks about. Then we will come to acids, bases, right? That's what we have discussed. Acids, bases and salts. So we have got acids, bases and salts. Now in the last class, I have discussed about Arrhenius theory, Bronsted-Lowry theory, and then we have discussed about Lewis theory. What is that Arrhenius theory talks about? Arrhenius theory tells that an acid is a molecule which will donate the H plus, and base is a molecule which will donate the OH minus. Now when it comes to Bronsted-Lowry theory, it tells that acids are H plus donors, but bases are H plus acceptors. Okay? And the last one is Lewis theory. So what is that Lewis theory talks about? Lewis theory talks about acids are electron acceptors and bases are electron donors. All of you have understood? So that's what we have discussed in the yesterday's class. So when it comes to pH, that's what I have started with the pH scale. When it comes to pH scale, as I told, it will be ranging from 0 to 40. It will range from 0 to 40. That's where we have the pH scale. So however, what is that pH? So pH is nothing but power of hydrogen concentration. That's what the P, power. Okay. So log of H plus concentration, negative log of H plus concentration. Now when I am telling log, that means to the base of 10. So to the base of 10. See for example, I have pH as 1 and I have pH as 2. So they differs with respect to integer as 1. So pH 1, pH 2. What is that difference? 1 is there. But if you take the H plus concentration, then they differs by 10 times. Whether I am clear? That's what the logarithmic scale, to the base of 10. The difference here is 10 times. If I take pH is equal to 3, then the difference will be from here to here, it will be 100. So it will be 100. So that's what it will go on increase. Difference will be increasing by 10 times. So all of you have understood. So that's what the pH scale talks about. Fine. So hagadre, what is that pH means? pH is nothing but negative logarithm of H plus ion concentration. Now in the last class I was telling that why it is 0 to 40. Now if I take water, hydrolysis of water, H plus OH minus. Okay. Now if I apply equilibrium constant for this, so K equilibrium is equal to H plus OH minus divided by H2O. Okay. So what I mean to tell here is a water molecule under equilibrium, it will be present like this. Therefore they will tell that water is neutral because it will give H plus also, OH minus also. That's what they will conclude. Water is neutral. So based on that we have written the equilibrium expression for this. Now if I take the concentration of water, we can calculate the molarity. For example, the given mass of water can be 1000 grams and molar mass of water is 18 grams. So the answer will be 55.5 molar. So whatever water concentration is there, that one we can calculate. So by considering that 1000 gram, because density of the water is 1. Okay. So 1000 gram in 1 liter. Okay. So 1000 gram given mass divided by the molar mass. So that's where we have got the moles, 55.5 moles. Okay. So that is the concentration of water. Okay. Now equilibrium constant they have calculated as 1.8 into 10 to the power of minus 16. Equilibrium constant they have calculated as 1.8 into 10 to the power of minus 16. All of you have understood this one? Any doubts? Why pH scale is 0 to 14? That's what we are identifying now. Why it is 0 to 14? So all of you have understood this much? Any doubts? How come we got 55.5 moles and all? Any doubts? That is because 1000 gram divided by 18 gram. So given mass divided by molecular mass of the water, 18 gram. All of you have understood? Any doubts? Okay. So that's where we have the condition. Now I can rewrite the equation as 1.8 into 10 to the power of minus 16 is equal to H plus concentration OH minus concentration divided by 55.5. Right? So therefore if I cross multiply, so H plus concentration OH minus concentration is equal to 1 into 10 to the power of minus 40. So that's what the value we are going to get when you cross multiply these two. 1 into 10 to the power of minus 40. All of you have understood. So that's where we have the H plus OH minus concentration. Now what is log of 1? Log of 1 is 0. So 10 to the power of minus 14, that is 40, because log of 10 is 1. Okay, fine, I will write it down. Any doubts up to here? This is just a cross multiplication. Fine? Okay. So on further solving this one, on further understanding this concept, if you observe carefully, we can tell that this one has an ionic product of water, because H plus OH minus both are ions derived from the water. So therefore ionic product of water or ion product of water, that is nothing but Kw, will be equal to 1 into 10 to the power of minus 40. 1 into 10 to the power of minus 40. Right? So that's where the pH scale will range from 0 to 14 because it is based on the ion product of water. Okay? So dissociation constant of the water, it is based on that, therefore pH scale will be 0 to 40. Any doubts? Fine. So based on that we can tell that since H plus concentration and OH minus concentration is equal to 1 into 10 to the power of minus 14. So we can also write it as pH plus POH is equal to pKw, ionic product of water. So pH plus POH is equal to pKw. Important equation. Remember this one also. So pH plus POH is equal to pKw. Fine? All of you have understood? Any doubts? Okay, na? So next, why pH of a neutral solution is equal to 7? That one also we can justify. Why pH of a neutral solution will be 7? So that's very simple. At neutral condition, what is that? H plus concentration will be equal to OH minus concentration. Right? So therefore we can write it as H plus square is equal to 1 into 10 to the power of minus 40. All of you are understanding? This one I am taking it as H plus square because at neutral condition H plus concentration is equal to OH minus. So based on that I will take this one as H plus square is equal to 1 into 10 to the power of minus 40. So therefore we can clearly tell that H plus concentration will be equal to 1 into 10 to the power of minus 7. So 1 into 10 to the power of minus 7. So that will be the H plus concentration. Now we will calculate the pH. What will be the pH value for that one? Okay? See, for example, H plus concentration is given. Now we know that pH is equal to minus log of H plus concentration. So therefore pH is equal to minus log of 1 into 10 to the power of minus 7. Okay, so that is the value we have got, H plus concentration. Now therefore we can write it as minus log of 1 plus minus 7 log of 10. Whether I am clear? According to log rule, 10 to the power of minus 7 is nothing but minus 7 into log of 10. Okay? Since it is a multiplication, it will become plus. So therefore log of 1 plus minus 7 into log of 10. So what it means? It means 1 log of 1 is 0 plus minus 7 log of 1 is 10 is 1. Log of 10 is 1. So therefore minus minus will become plus. So pH is equal to 7. So therefore at neutral condition where H plus concentration will be equal to OH minus, at that particular condition pH value will be 7. All of you have understood? Any doubts? So based on that 10 to the power of minus 7 is nothing but 7 because we have the minus log of H plus concentration. Since there is a minus sign, whatever minus 7 is there, it will become plus. All of you have understood? Any doubts? If you have any doubts, you can ask. Okay. So that's where we have the pH. Fine. As I told, based on this, sir, will they give log value as we have not yet learnt about log? Okay, log value. Anyway, they will give log book. They will not give log value. They will give the log book. Fine. So I will teach now. How to see the log. We will solve one or two problems. During that time I will teach. Okay. So based on that I can tell that when pH is equal to 0, what will be the H plus concentration then? When pH is equal to 0, what will be the H plus concentration? Anyone? It will be equal to 1 molar. It will be equal to 1 molar. So now when pH will be equal to 1, so naturally H plus concentration will become 0.1 molar. Right? 0.1 molar. Right? So that's what we are going to get the concentration. That means here it will be 10, here it will be 10 to the power of minus 1. So log of 10 is 1, right? So here it will be 10 to the power of minus 1. pH2 means 10 to the power of minus 2. pH3 means 10 to the power of minus 3. It will go on like this. Fine? All of you have understood? So that's how we should understand the pH value. All of you have understood? Any doubts? Okay? So same way, when I am talking about pH is equal to 2, so naturally H plus concentration will be equal to 0.01 molar or 10 to the power of minus 2. Right? So minus 7 became 7. Same way, minus 2 will become 2. Okay? So now if I take pH 3, naturally H plus concentration will be 0.001. Okay? So 10 to the power of minus 3. So 10 to the power of minus 3. So that's how it will go on. Fine? All of you have understood? So that's how we should understand the pH scale or pH value. Okay? Now I will give some problems related to this. We will solve one or two problems related to this. Okay na? Hagadre, all of you write it down. All of you write it down. A solution is 1 minute. A solution is 0.055 molar of HBr. What is the pH of the solution? What is the pH of solution? So that is the question. So what they have given? They have told that a solution is 0.055 molar of HBr, hydrogen bromide. What is the pH of the solution? Fine. Now we should know that hydrogen bromide is a strong acid. Hydrogen bromide is a strong acid. So it will be completely dissociated when it is added to the water. It will be completely dissociated. So based on that we can tell that since HBr is a strong acid, so definitely therefore H plus concentration will be equal to 0.055 molar or we can write it as 5.5 into 10 to the power of minus 2 molar. Scientific notation. I have written in the form of scientific notation. Fine. So you can even go with 55 into 10 to the power of minus 3, but I have kept it as 5.5 into 10 to the power of minus 2. That is the concentration of H plus they have given. And they have asked us to calculate the pH of the solution. So now I can tell that pH is equal to minus log of H plus concentration. Right? So therefore minus log of 5.5 into 10 to the power of minus 2. 5.5 into 10 to the power of minus 2. Now I can rewrite this one as minus log of, or I will keep log inside, log of 5.5 plus minus 2 into log of 10. So this is what I am going to have. So log of minus, I have kept it outside. So log of 5.5 plus, here multiplication is there, therefore plus minus 2 log of 10. Okay now? All of you have understood? So this is because if I have a square, if I want to apply the log value for this, then it will become 2 log of a. It will become 2 log of a. Same way, I have a plus b. Now a multiplied by b. Now I want to apply log scale, log value for this. Then it will become log of a plus log of b. Same way I have a divided by b. Then I will be having log of a minus log of b. So these are some of the rule which we have to remember. So a square will become 2 log of a into b will become log a plus log b, a divided by b will become log a minus log b. So that's how value will be calculated. Fine? All of you have understood? So based on that, I have applied these rules over there. So because of that, 5.5 into 10 to the power of minus 2 will become log of 5.5 plus, because multiplication is there, minus 2 into log of 10. Okay? Now, I have to see the log value for 5.5. So I have to see the log value for 5.5. Now, please remember that log of 1 is equal to 0 and log of 10 is equal to 1 because it is to the base of 10. So therefore, whatever 10 is there in regular this one, in log scale it will become 1 because it is to the base of 10. So log of 1 is equal to 0, log of 10 is 1, log of 100 will be 2. Okay, log of 100 will be 2. So what I am going to tell here is, here it is 5.5. Here it is 5.5. That means less than 10. Less than 10. More than 1. That means it should be present between 0 and 1. All of you will agree with me? It should be present between 0 and 1. So therefore it should be in the decimals. It should be in the decimals. So I will make it as 0 point. I will make it as 0 point. All of you have understood. It's a common sense. Log of 10 is 1. Log of 1 is 0. But whatever we have got the value as log of 5.5. So 5.5 is present between log of 10 and log of 1. So that means between 0 and 1. That means it should be in decimals. So 0 point. Now I have to go to the log book. So there 55 value I should take. 55. because log of 5.5 we wanted to see, right? So that one we have made it as 0 point. So therefore I should see the 55. So 55 first column, 0th column, because after 5.5 nothing is there. So therefore 0th column I should see. So that's where I have got 7404. They have given as 7404. So 0.7404. Now this will be plus minus 2, and now what is log of 10? Log of 10 is 1. No need to see the log book only. So multiplied by 1. Okay, all of you have understood? Now I will write this one. I will continue here because below if I write you can't see. Now what I have got here is minus of 0.7404 minus 2, right? So minus 2. Now we have to subtract 0.7404 from minus 2. What will be the answer you are going to get? Anyone? Tell me the answer first. What will be the answer? Point 7404 minus 2. Okay, 1.25. You can stop it there. 1.25. Absolutely correct. Or you can have the further decimals also. Okay? Okay. Minus 1.2596. Okay, fine. So it will be minus of 1.2596. So naturally, therefore, pH will be equal to minus will become plus 1.2596. Oh, you can't see that. So minus will become plus. So therefore, pH will be equal to 1.2596. That will be your answer. Fine. So that will be your answer, 1.2596. Any doubts with regard to this one? How we have solved, all of you have understood? So it can be expected in your board exam also, or even your competitive exam also. All of you have understood this one. Shall I remove this? So the final answer is 1.2596. It will not be negative, it will be positive only, because outside the bracket we have the negative sign. So negative it will become positive. Okay na? Fine. Another problem, can you take it down? If you have any doubts, you can ask. Okay. So write it down. A solution is 0.00025 molar HCl. A solution is 0.00025 molar HCl. What is the pH? What is the pH and pOH of the solution? pH and pOH of the solution. Can anyone find out first H plus, that means pH? I am waiting. Try to solve it. First find the pH value. Anyone? Okay. So what we have to do is HCl is a strong acid. All of us we know. When HBr can be a strong acid, naturally HCl is much more stronger acid. So, or not sorry, HCl is also a strong acid. Compared to HBr, it is slightly weak, but still it is also a strong acid. HCl is a strong acid. So, based on that, we can tell that. So, therefore, concentration of H plus will be 0.0025 molar or 2.5 into 10 to the power of minus 4 molar. Scientific notation. So 2.5 into 10 to the power of minus 4 molar. Fine. Now I can apply the pH calculation. pH is equal to minus log of H plus concentration. So therefore minus log of 2.5 into 10 to the power of minus 4. 2.5 into 10 to the power of minus 4. Now further I can write it down that minus log of 2.5 plus minus 4 into log of 10. Right? So that's what we are going to get. Now what I should do? 2.5, once again it is between 1 and 10. Right? 2.5 is once again between 1 and 10. And we know that log of 1 is equal to 0. So log of 10 is equal to 1. So therefore it should be in decimals. So same thing I will write here, minus. So 0 point. I should see the value for 25. I should see the value for 25. So 25 and first column. So in 25 first column 39, okay, 3602. Oh, final answer. Okay. Why minus, Kritik? Okay. So we will cross check. Not minus, it should be positive only. So 25 is 3979. So 3979. Okay. So 25 zeroth column. So 3979 plus minus 4 into 1. Okay. Now further solving that, it will become minus 0.3979 minus 4. So that will be 021, 3.6021. Okay. So it will be minus 3.0621. So minus will become plus. Therefore, pH is equal to 3.0621. Correct? So 6021. That is the pH value. We are halfway. That is the pH value. So someone has written 0.6021. Why 0.6021? Okay, 3.6021. pH value will be 3.6021. Now it is halfway. We have to calculate the pOH value. Anyone? What we should do? pH we have calculated. Any doubts up to here? Okay, fine, Ullas, fine. So any doubts up to here? We have got the answer as 3.6021. Any doubts? So pH value we have calculated. Next we have to find out what is pOH. How to find the pOH value? to find the pOH value? Okay, yes, Sanya. How to find the pOH value? We should use the equation pH plus pOH is equal to pKW. So pKW is nothing but 40. So therefore pH plus pOH is equal to 40. 1 into 10 to the power of minus 14 was there now. Since we have taken pKW, it can be written as 40. Fine. So now substitute the value. We have got the value as pH value as how much? So 3.602. So 3.602 plus pOH is equal to 14. So therefore pOH is equal to 14 minus 3.602. Calculate and tell me what will be the answer. So it will be y minus 14 minus 3.602 is that na Kritik. So don't mistake with symbol and all. It will be approximately 10.4. So it will be approximately 10.4. pOH value will be 10.4. Fine. So that's what we have the calculation, pH calculation and pOH calculation. How come we got 14? All of you know, right? Because Kw is equal to 1 into 10 to the power of minus 14. Okay na? So therefore pKw is equal to 14. Because of that value pKw will be 14. So you should not forget these equations and all. Fine. Okay. So therefore pOH will be 10 to 10.4 or we can go with exact values, no doubt. Okay na? So this is with respect to finding the pH of a given solution. Finding the pH of a given solution. Fine. So shall we move to the next? Then we have another important concept within the acids only, that is weak acid and strong acid. Weak acid and strong acids. Just now we have discussed that hydrogen, bromide, HCl, they are all strong acids. Right? They are all strong acids. For example, in our laboratory we have the HCl. So which will be, when it is added to the water, it will completely dissociated as H plus Cl minus. That's what the arrow talks about. It will be completely dissociated. Whatever HCl we are going to take, everything will be converted into H plus Cl minus. But I have acetic acid, CH3COOH. Now in case of the acetic acid, it will be like this, CH3COO minus plus H plus. So what is happening here? Here, if you observe the arrow, backward is longer, this one, and forward is a smaller one, right? So that shows that many of the acetic acid will remain as acetic acid only. They will not get converted into acetate. Fine? So whatever is on the left hand side, it is an acetic acid, and whatever is present on the right hand side, it is acetate. Okay? So therefore, if I want to write equilibrium, K equilibrium, then it will become acetate concentration into H plus concentration divided by acetic acid. Divided by acetic acid. Right? So since we are talking about dissociation, of acetic acid as acetate and H plus, dissociation constant. So therefore we can also call it as Ka is equal to acetate concentration into H plus concentration divided by acetic acid concentration. Fine. So therefore we have the Ka as dissociation constant of the acid, which is nothing but equilibrium constant only, right? But we will talk it as dissociation constant of the acid. So I will write it here. So therefore Ka is dissociation constant of acid. Dissociation constant of acid. Now same thing, if I apply for HCl dissociation, then I can write it as Ka is equal to H plus concentration Cl minus concentration divided by HCl. Right? Now I will consider for HCl as K1 and I will consider for acetic acid as Ka2. Right? Now you should tell me which value will be greater, Ka1 value or Ka2 value? Which will be greater value? Ka1 value or Ka2? And HCl is a strong acid, acetic acid is a weak acid. Everything is on the board. Which value will be greater, Ka1 or Ka2? You can just mention greater value. Either Ka1 you can write or Ka2. Darshan has written as Ka1. Whether all of us will agree with that? All of us will agree with him? Okay. Naturally, we are in democracy, right? So we have to agree with all of you. That is correct. Where Ka1 value will be greater than Ka2. Ka1 value will be greater than Ka2. Simple logic. In the denominator, in case of the HCl, nothing will be there. Everything will be converted into H plus Cl minus. But here, maximum amount of acetic acid will be present, which is in the denominator. So naturally, Ka2 value will going to be decreased. It's going to be decreased. So based on that, we can tell that Ka1 is greater than Ka2. So what can be the conclusion by this? What we can conclude by this particular values? What we can conclude? For HCl, Ka1 value is greater compared to acetic acid. So we can conclude that for strong acids, dissociation constant will be greater compared to weak acids. Same way we can apply for base also, where Kb is nothing but dissociation constant of the base. Okay, instead of Ka, we can write it as Kb. So for strong acid, Ka will be greater compared to weak acid. All of you will agree with me? Fine. Now, in some of the cases, we have the polybasic acids. What I mean to tell here is where one acid can neutralize more than one base. For example, if I take HCl, in case of the HCl, if I treat with the sodium hydroxide, so that's where I am going to get NaCl, a salt, plus water as the reaction, right? But if I take sulfuric acid, and if I treat with sodium hydroxide, naturally I will be requiring 2 molecules of sodium hydroxide. So where I am going to get Na2SO4, sodium sulfate, and then I am going to get 2 molecules of water. So what is happening here? For HCl, it can neutralize one base, but when I am talking about sulfuric acid, it can neutralize 2 base. That means 2 molecules of sodium hydroxide. That means it is a polybasic acid. Hagadre, what do you mean by that? So when I am talking about sulfuric acid, when it is added to the sodium hydroxide solution, that means I have got sulfuric acid, which will be dissociated as H plus and SO4 minus 2, sorry, HSO4 minus, it will be dissociated as HSO4 minus, okay, which is called as bisulfate ion. Okay, and further, whatever bisulfate is that, it can be dissociated as H plus sulfate minus 2, SO4 minus 2. That means there can be two values, Ka1 and Ka2. There can be two values, Ka1 and Ka2. So that means some of the acids, since they can release more than one H plus, so they will be having more than one Ka value. So in case of the sulfuric acid, we have Ka1, Ka2. Now I will give a statement that Ka1 always it will be greater than Ka2. Always it will be greater than Ka2. So what do you mean by that? That means one H plus will be released by sulfuric acid very fast, but second H plus will be released after some time. Slowly it's going to release. Please remember, sulfuric acid is a strong acid, no doubt, because one H plus will be released very fast. But when it comes to second H plus to get released, it will act as a slightly weak acid. So therefore Ka1 value will be greater than Ka2. All of you have understood? So don't think that sulfuric acid is going to release all the H plus at once. No. First H plus will be released very fast. Second H plus will be released after some time. That's what we can see there. Okay. So that's where we have the one of the example for polybasic acids. Now same way, not only 2H plus, we have some of the acids which can release more than this. Right? That means orthophosphoric acid. That means H3PO4. That is nothing but orthophosphoric acid. So naturally this molecule is going to release one H plus and it's going to form H2PO4 minus 2. Okay, H2PO4 minus 2. Then this H2PO4 minus 2 is going to dissociate as H plus HPO4 minus 3. Minus 3. For 1 minute. It should be minus and here it should be minus 2. Okay. And finally, HPO4 minus 2 will be dissociated as H plus and phosphate. H plus and phosphate. Now naturally how many dissociation constant? Ka1, Ka2, Ka3. So naturally Ka1 will be greater than Ka2, which will be much greater than Ka3. So that's where we have the dissociation constants. Fine? All of you have understood? So that means as the Ka value increases, what indicates? That particular acid will be a strong acid. What do you mean by strong acid? Strong acid means it can release the H plus very fast. Okay, so that's where we have the dissociation constants for the acids. Fine? Give me another 2-3 minutes. So we have a relation where we can tell that pKa, is equal to minus log of Ka, same as that of the pH. pK is equal to minus log of Ka. All of you have understood. Just as pH is equal to minus log of H plus concentration, same way we have pK is equal to minus log of Ka. So we can also write it as pK is equal to log of 1 by Ka. So what I mean to tell here is Ka value and pK value, they are inversely related to each other. Ka value and pK value, they are inversely related to each other. That's what this formula talks about. Remember this formula, which is same as that of the pH. But there it is H plus concentration, but here it is dissociation constant. Fine. So that's where we have the pK relation with Ka. So how they are related? Inversely related. That means as the value of Ka increases, pK value is going to decrease. Okay? So that means we can conclude that for strong acids will have lower pK value. Lower pK value. And weak acids will have higher pK value. Exactly opposite to that of the Ka. Don't get confused. It is exactly opposite to that of the Ka. So strong acids will have lower pK value and weak acids will have higher pK value. So that's how we can give the statement. Exactly opposite. Here only you can write it down. So strong acids will have higher Ka value and weak acids will have lower Ka value. So that's what based on the equation we can tell. Okay, all of you have understood. So that is the statement what we can conclude from these particular equations. Fine. Any doubts? Anyway, I will stop here. So tomorrow we are going to discuss about salt. Then we are going to discuss about the buffer solutions. Fine. And please practice some more problems related to pH calculation. Okay. Any doubts up to here? Or any doubts related to today's class? Okay, then I will stop here. If you have any doubts, you can ask me questions. You can get it clear. Okay, no doubt. Okay, then thank you. Thank you very much. Take care. Okay, so tomorrow we'll continue with the class. Thank you very much. Oh, Rakesh, I got afraid when you told no, sir. Then I thought that no, sir clearly understood. Okay, fine. Okay. Thank you. Thank you.